Next is zeros from graph of a polynomial. We know how to find zero of a polynomial. Then if the graph of a polynomial is given, we can find the zeros. You are familiar with this graph sheet, correct? Have you seen this graph sheet? So let me explain one example. Consider a polynomial x square minus 1. Let me denote by a letter y. Okay, x square minus 1 is a polynomial. Is it okay? So how to draw the graph of this polynomial? Actually, drawing the graph is not there in our syllabus. But in order to make you understand this concept, I have to explain graph. So y equal to x square minus 1 is given. How to draw the graph representing this? You just substitute some values for x. I mean, for example, when x equal to 0, what is y? It's very simple to draw the graph of a polynomial. Simply put some values for x. If x equal to 0, what is y? Put x equal to 0 here. Y will be 0 square minus 1. 0 square minus 1. It will be equal to minus 1. Meaning that when x equal to 0, y is equal to minus 1. When x coordinate 0, y coordinate minus 1. We can say like that. You studied in the, last year you studied coordinate geometry. When x coordinate 0, y coordinate is minus 1. Meaning that 0 comma minus 1. When x is 0, y is minus 1. Where is 0 comma minus 1? Do you remember coordinate geometry? You studied last year. 0 comma minus 1 is here. I will show you. Here. X coordinate 0, y coordinate minus 1. It is here. 0 comma minus 1. Similarly, I am going to substitute x equal to 1. What is the value of y? The value of y will be, put x equal to 1, 1 square minus 1. 1 square minus 1 will be 1 minus 1, 0. Meaning that when x equal to 1, y equal to 0. When x equal to 1, y equal to 0. 1 comma 0, it is here. Is it correct? 1 comma 0 is here. X coordinate 1, y coordinate 0. Let me substitute some more values. When x equal to 2, what is y? Y will be 2 square minus 1. 2 square minus 1, 3. Meaning that when x equal to 2, y equal to 3. 2 comma 3. Where is 2 comma 3 in this graph? When x equal to 2, y coordinate is 3. Correct. The point is here. When x equal to 2, y is 3. Let me find out some more points. Similarly, when x equal to 3, let me go up to 3. When x equal to 3, y equal to 3 square minus 1. Correct? 8. 3 comma 8, it is a much larger. 8, there is no space to mark 3 comma 8. So let us skip it. In this way you can put x equal to 3, x equal to 4. Okay. Now let me substitute the negative value for x, like x equal to minus 1, x equal to minus 2. Let us see what happens. If x equal to minus 1, what is y? Put x equal to minus 1 here. You will get minus 1 square minus 1. Minus 1 square will be 1, correct? 1 minus 1, 0. So when x equal to minus 1, y equal to 0, minus 1, 0. minus 1 0 is here, correct? Minus 1 0 is here. Let me substitute one more value. X equal to negative number minus 2, y equal to minus 2 square minus 1, minus 2 square minus 1, 4 minus 1, 4 minus 1 3. So when x equal to minus 2, y equal to 3. When x equal to minus 2, y equal to 3. Minus 2 comma 3, where is that point? It is here, minus 2 comma 3. Similarly, we can substitute x equal to minus 3, minus 4, etc. Okay. And in between 0 and 1, you may substitute x equal to 0.5, 0.6, etc. But I don't want to show all the points. Then the graph is obtained by joining these points smoothly. Smoothly join the points like this. Understood? Smoothly join these points like this and extend it a little bit. This is the graph of the polynomial y equal to x square minus 1. Polynomial x square minus 1 is denoted by y. The drawing the graph is not there in our syllabus, but from the graph, if the graph is given, we can easily find out zeros. So if once this graph is given without any factorization, you can find out the zeros. I will tell you, this graph cut x-axis at minus 1 and 1. Is it correct? I mean, when x equal to 1, the polynomial value is 0. So when x equal to minus 1, the polynomial value is 0. So the zeros of the polynomial, from the graph we can find the zeros of the polynomial. Okay, if the graph cut x-axis, that value on the x-axis represents 0. So if the graph is given, remember, if the graph is given, we can easily find out zeros. Just look at the point at which the graph cut x-axis. The graph cut x-axis at plus 1. So plus 1 is a 0. And cut x-axis at minus 1. Minus 1 is a 0. So we need not do any factorization if graph is available. And remember, we don't look at y-axis. We look at the points at which the graph cut x-axis. Okay, cutting y-axis we will not look at. At which point the graph cut x-axis, that point represent zeros. Okay.